Okay. All right, so I was chatting with, hi all, hi troops, hi, da-da-da. Okay, so I'm next door again because I got some Bio 2 students over, and I haven't zoomed in, so I was hoping you'd be able to see the periodic table as quick as possible, so I moved. I just want to go over where I left off on Tuesday about the mass to moles and moles to mass and a couple little properties. I've been grading your coloring guides for those, the periodic table coloring guide. A couple of you, also don't forget to send me pictures of the colored part. You sent me questions, so on. So if you submitted half of it, submit the rest of that, or just send it to me in an email of another picture since it's already submitted, so I can grade that part too. No big deal. I'm also taping this, so if you miss anything as to what we're doing, what we're going to do, what do we got going on for next, so you can watch this part, you know, if you missed out on a couple things there. So I'm looking at my camera. That's funny, I keep looking at this camera, but your camera, so I'm not looking at like a crowd. I just trying to figure out which camera do I look at. Do I look at the video camera I'm taping for you guys? So anyway, okay, so real quick, so we spent time with the periodic table here, and the biggest thing I want to focus on today, all right, is just give me really good, about 15, 20 minutes of your really good attention here, is reiterating about the atomic mass and number, okay? So I'm just pointing right here at nickel since it's right here in front of us, right? And you notice there's a symbol, obviously, Ni for nickel. 28, remember, is the atomic number, which is the protons, which is also the electrons. But more important, we're going to focus on today is this atomic mass, okay? And right here it says it's 58.69, okay? So what I want all of you to do, and remember this, is to round up to the whole number. So i.e. example, that one place back, 58.69 so we get the same answers. This would be 59. This would be 64. 65.3 would be 65, okay? You know, 0 to 3 stay, 4 and up, round up. Okay, no, 0 to 4 stays the same. No, 0 to 3 stays the same, 4 and up, round up, right? Yeah, okay. So you're just rounding up the whole number, so do not worry about decimals for our atomic mass, okay? And that's important because you're doing simple math today, or the little simple assignment, kind of what you saw also with your worksheets from Tuesday that I uploaded for you guys to practice as well, okay? So I can't reiterate that enough about the atomic mass, because what this is telling you people is this atomic mass right here underneath the symbol is the same as saying that is 1 mole of that element, okay? So if I looked up here at boron, which is 10.8 or 11, and I said I had 1 mole of boron, that'd be 11 grams, okay? That converts to grams, mass is in grams. If I said I had 2 moles of boron, that'd be 11 times 2, 22, and so on. So every mole that is represented for that element, it's going to be times by that, okay? So if I said I had 3.5 moles of boron, I would just take this times 3.5, and that would tell me how much grams or how big a mass that is, okay? So for today, all right, with that conversion, I'm going to turn my camera here. So actually, I'm just going to pick it up here, move it right over here like that, so you see the blank whiteboard, okay? All right, so hopefully everybody, so I don't have to go back and forth, you see, you have your periodic table sitting there to your left, right, or in front of you, please, okay? Because I can see mine over my shoulder. All right, so a little recap on that formula, because I realized I ran out, if you were online with me Tuesday, I ran out of space, didn't know it, so the video got cut off by about 3 minutes right when I was explaining the iron moles to mass and mass to moles thing. So I said, well, that's okay, because that's what I'm going to pick up on Friday for you guys to reteach that, okay? So real quick recap. When I have my mass, okay, which is in grams, okay, all right? Somebody needs to mute their Miles. Miles. Thanks, bud. Okay. Yeah, your music was coming through there. Okay. So I got my mass, which is my grams. Okay. And when I have the mass and I'm asking for what is the moles of that element, okay, I'm going from a larger to a smaller. So it's going to be division. Okay. All right. And then when I'm going for moles, if I have the moles and I need to know the mass, okay, which is the grams, okay, real quick reminder on that, all right, then that means I'm going to times, okay, I'm going to times that. make sure it gets everything in here real quick. Okay, I'm going to do times, all right? So, i.e. example, real quick example here. If I have sulfur, which is the symbol of S, and we said the atomic mass of sulfur is 32.066. So we know that 1 mole of sulfur here is equal to 32 grams. Okay, everybody see that? All right, that's right from the periodic table. You can always have this right in front of you all the time. Okay, right next to you. You will never have to memorize those type of stats. Okay, so that's the cool thing. I'm just making you guys familiar with the answers in front of you. Just know where to look for them. Okay, so what I would be asking if I said if you had, let's see, can you still turn a little more here so you can see me right? A little more. If I had 4.5 moles of sulfur, okay, in a sample, and I wanted to know how much is it in grams. Okay, so I have moles, here's my little formula, and I'm going to mass, so that means it's going to be a simple times problem. So once again, what do I times? So this value is always going to be the molar mass, the atomic mass, okay? Depending on which direction I'm going, depends on if I'm going to times or multiply. In this particular case, I'm going from moles to mass, so I'm going to times. So that would be, I take my 4.5 moles times by the atomic mass, which is 32. Real simple conversion, almost no different. 4.5 times 32. And the answer should have came out in the calculator, 144 grams. So, what it's telling you is, if I had 4.5 grams, or 4.5 moles of sulfur, and I want to know how many moles of that, that's basically 4.5 chunks of the atom sulfur, or the element sulfur, that whole thing would weigh 44 grams, okay? That's what it's saying, all right? And that's the main focus of what you're going to be doing today, all right? Although I did throw one little extra thing to challenge you on those problems, all right? So if you happen to have a split screen and you were to click on the worksheet for today, okay? Or not, that's okay. I don't have my camera in here. So the first 6 are just asking you for the molecular weight of these compounds. Okay, so I'm gonna do the first one with you here as a sample. I'm looking for, oh, there it is. I'm gonna do the first one with you here for a sample. Okay? All right. So the first one, guys and gals, is on your sheet is NaOH. It's this right here, NaOH. So basically, hopefully you recognize that as seeing I got 3 elements. I got sodium, I got oxygen, and I got hydrogen. So all I want to do is, the question is asking you, what's the whole mass? Okay, that's easy. So I just want to look at the weight of each one of these elements. So I look over my periodic table, and Na is clear over here. So it's 22.9, so that'd be 23. So that's the molar mass of one of those is 23 grams. Oxygen, O, is right here, so that's 15.9, so that'd be like 16. Hydrogen is clear over here, that's 1.0. So the answer is 23. I can do this in my head real quick. 6, 7, 8, 9, 10. Carry the 1, 2, 3, 4. So the molar, the total mass of that, molecular weight of that is 40 grams. That's all you had to do. Okay, I just wanted you to practice that. Identify, recognize that you don't need to know that this is sodium hydroxide. I knew that, but you don't. You may or may not. But what I want you to recognize is, oh, that's sodium, that's oxygen, and that's hydrogen. And what would those 3 atoms of those elements combined, what would they weigh? Well, just look at the atomic mass, and that's what we did. Oxygen was 16, hydrogen was 1, sodium was 23, added them up, comes up to a mass of 40 grams, okay? So that's how you do, that's the first one on the worksheet, and then you got 5 more like that, okay? Then the other problems on there are just what we were talking about, where you're going to convert either mass to moles or moles to mass, okay? So it's either going to be a 1-step multiplication or a 1-step division problem, okay? All right? Like I said, if I'm going moles to mass, All right, it's going to be a times. I'm going to take the moles given times by the molar mass here, or the atomic weight. That'll give me my weight in grams. If I've got grams and I got to go to moles, I'm going to take those grams and divide it by the weight, and that'll give me a smaller answer, and my answer will be in moles. Okay? So I'm going to look at the first one there. The first one, number 3, says, how many moles are in 22 grams of argon? So argon happens to be right here, so I picked that one. So I have argon, okay? And it says I have 22 total grams of argon, okay? And it wants to know, how many moles do I got? Okay, so if I've got 22 grams, and I'm trying to go to moles, isn't that mass to moles? If I'm going mass to moles, I'm going to multiply or divide. Somebody say it, multiply or divide. No, I don't want to.
Multiply?
Okay.
Wait, no. It would be divide.
Exactly, how to go, because think, big unit to a smaller, it takes a lot of these guys. So yes, I'm going to simply divide. So all I got to do is take 22 grams, okay? All right, and I'm going to divide it by the molar mass. Argon's right here, it's 39.9, that's 40. So I'm just going to take 22 people, okay, divided by 40, and that gives me 0.55 moles of argon. And that's my answer. Very simple, okay? So it said, how many moles are in 22 grams of argon? So 22 grams of argon, how many moles? Not even, it's a little over a half a mole, 0.55 moles, okay? Makes sense. And you kind of see the correlation there, right? Because if I got 22 grams of it, that's almost half, so probably eyeballing it 40, so yeah, that puts a little so you can see the correlation there. If the mass of argon is 40 and I got 22, I'm just a little over half, so that makes sense why that's 0.55, or just a little over half of the molar mass, okay? So does that make sense? Okay. So if you're looking at the worksheet, if not, that's okay, right? It's listed there under the 18th, but you have those 5 problems I just said of converting the total mass, and then you either converting a mass to moles or a moles to mass of a particular element, okay? And I think I gave you, let's see, oops, I didn't upload the second one. There's the first one there that's only 8 of them, and then I had another one that was like another 10, no big deal, that it didn't load up at all. Put it below it. You'll see it. It'll say December 18th, worksheet number 2, but it's about the same size as that one. It doesn't take you very long. I didn't want to overwhelm. The biggest thing is, people, do we understand now when I say, what is a mole? Oh, that's 1 unit of whatever it is on the periodic table. And what is the mass of it? Just look at the atomic number. I'm sorry, the atomic mass. Yes?
Is the worksheet in our math book?
This one is not. So you can just write the answers on notebook, all right, and submit it that way. This was an extra one because it didn't have enough.
Okay.
The practice problems that were in your workbook were more wordy problems, and I just wanted to focus on the math part today, okay? So, yes, there are some ones in there, but they're more wordy problems, kind of like we did before we went for break on some other stuff, okay? So, you can download as a PDF right on it if you have a printer, or if you want to come up and get a copy here, no big deal. Like I said, I think I put on there this one and the other one I haven't uploaded yet because I didn't realize I didn't upload both of them until just now. Which is no big deal, is Tuesday by midnight, so the last day, okay? So next Tuesday is just a matter of, I'm not going to start anything new, all right? So your goal between now and Tuesday of class is making sure that you're caught up with everything so you can enjoy your 2 weeks off and don't have any homework over break, okay? So that's our main objective, all right? So we're not, unless you have to meet with me, because I'll be up here and need to bring something up, I won't require you guys to log on Tuesday during 4th hour, okay? All right? But if you, like I said, if you need help with something, that's fine. I'm not going to start any new homework or something over the break. So your goal is to make sure everything is caught up and finished. Coloring sheet, timelines. I still see several of you haven't turned in your timeline, okay? So you need to get that done, all right? Your timeline project, all right? So make sure you get that done as well, all right? Because that's your goal. If you have any back order stuff, then that's just your time between now and Tuesday to get that stuff caught up, okay? All right. So does anybody have any questions over this? I taped this, so if you had questions as to what I said, forgot, you can watch it. I think it was a whole, 15 minutes max. So if that helps re-spark your brain on not only how to do this, but what to remember to do or what we're going to be doing, that's why I tape it, okay? All right, any questions? All right, no good, all right. Okay, so I will upload the little short video just so you have it, okay? That way mom, dad, whoever asks us what you do today, well, we could, and they can watch it with you. Sometimes, you know, I actually had somebody email me. I won't say which one of your parents, but I appreciate it. But they said it was helping them help you get your work done. So I was like, cool, I'm glad. You know, like I said, it's benefiting more than just, you know, the student itself, because that is, we're all on the same page here trying to get everybody to learn these little topics, okay? So, so if you don't have anything else, I'm gonna shut my recording off, all right, so you don't have to keep listening to me babble. And then I'll get the second little worksheet uploaded when I walk back over to my room, and that'll be it. Okay?
I have a question.
Yes, Ms. Torres, what's up?
So last time that we did the lecture, I took some notes, and so like with the element, the little number, it means like the proton and the nucleus, right?
This okay, I'm gonna turn my camera. So the number, like krypton here is 36. Is that what you're saying? Yes, that is the number of protons.
Is it also the number of like electrons?
Correct. Correct. Right. So
it's both.
yeah. So that's the one thing. The neutrons are what's different. So while you're asking that, that's a good question. So since right here it's in front of you, can you see krypton here I'm pointing at? Okay, number 36.
Yes.
Okay, it has an atomic mass of 83.8, or just round up to 84. So what this is saying is, change the proton, doesn't that change the element? Because think about it, if this went from 36 to 35, now it's no longer krypton, it's bromine, okay? So the reason why it's on this, remember, at this point, before the elements become active or energized or ionized or charged, doesn't it make sense that if I have 36 protons, which are pluses, I'm also going to have 36 electrons, which are negatives, plus, minus, plus, minus, plus, minus, and that gives me a neutral charge, okay? Does that make sense? So then that's why the neutron in the nucleus is no charge. So if you wanted to say, okay, what's 36 from 84, that number will tell you how many neutrons is in the nucleus.
Okay.
All right, and you can add more neutrons. All that does is make the nucleus bigger. Okay.
Okay.
All right. Does that help?
Yes.
And those are what we call isotopes. Remember that term? You've heard it before. That's an isotope. When we start talking about isotopes, we're talking about the same element that has more or less neutrons in its atom. Okay. Good question. Anybody else? Okay, well, if you don't have any other questions, you're free to work on that. Ms. King, I'll go ahead and leave my camera like I always do or whatnot, so if you need something from me, or if any of you guys who just holler, hey, Meyer, and I'm here in the room because I'm helping some other students with Bio 2 stuff as well, okay? All right, so if I don't see you from here on out, I think, hey, guys, have a good, safe holidays, enjoy your time. You know, I'm not going to give you any homework. All I ask you to do is make sure you get all caught up with what from today and the past by the end of the day on Tuesday, so you can enjoy your break, okay? All right? Sound good? Perfect. All right. So, all right, you guys are good to go. All right, I'm going to shut the camera off here, my video.